All right, moving on to our next example, we're going to continue to solve our rational equations. We're going to multiply every term by the denominator or a common denominator if you have more than one fraction like we have in this example. We're going to identify our domain, all that good stuff. So I'm going to rewrite the problem. I do want to make sure I know what all the denominators are. So x plus 5, x plus minus 3. Actually, that should be an x minus 5. So if you guys have x plus 5 in your packets, please change that to a minus 5. All right. The thing here is this denominator. I want to see this in factored form. I want to know what the factors are. That's going to make it easier to identify what a common denominator is. So I'm going to rewrite the problem and I'm going to space everything out because I want some space for this. You'll see why once we start solving. So we have 1 over x minus 5 plus x over x minus 3 equals 2 over, and then I'm going to factor this as I rewrite it. So it's just an x squared. There's no GCF. Are there factors of 15 that add up to negative 8? So your factors of 15 that add up to negative 8 are negative 5 and negative 3. So x minus 5, x minus 3. Okay, before we continue on, let's just have a moment and think about our domain. Domain, we need to make sure that we never let our denominators equal 0. So in this fraction, we would have to avoid a 5. We would have to avoid a 3. Over here, we would have to avoid that same 5 and 3. So we're going to make sure that our x's do not equal a positive 5 and a positive 3. Okay, now to solve an equation with fractions, do the fraction trick. Multiply everything by a common denominator. So what would a common denominator be when our denominators are x minus 5, x minus 3, x minus 5, x minus 3? So maybe off on the side, let's think about what a common denominator would be. Well, it has to have an x minus 5 in it. So I know I need an x minus 5 in our common denominator. So that takes care of that x minus 5. I need an x minus 3 for that denominator right there. And then over here, is there anything new? Well, x minus 5 I've got covered, x minus 3 I've got covered. So I think we're good. That's our common denominator, x minus 5 times x minus 3. So we're going to multiply every term by that x minus 5, x minus 3. And when you multiply, just keep in mind that is over 1. So we are multiplying this up to the numerators. So we're going to multiply x minus 5 times x minus 3. Here, x minus 5 times x minus 3. X minus 5 times x minus 3. All right, so we multiplied every single term by our common denominator. Then what we get to do is go in and reduce these fractions. So in this first one, this x minus 5 cancels the x minus 5, leaving you with an x minus 3 times 1, which is just x minus 3. Plus, now the second fraction, the x minus 3's will cancel, leaving you with an x times x minus 5. In our last fraction, our x minus 5's cancel and our x minus 3's cancel, leaving us with just a 2. And now this is the equation we have to solve. So the x minus 3, we're just going to carry down an x minus 3. I can see we have some distributing to do with the x. So x times x is a positive x squared, so plus x squared. X times negative 5 is a minus 5x equals 2. We're going to solve for x. Because I see that we have an x squared, let's get everything on one side, set this equal to 0. So I am going to subtract 2 from its like term over here. I'm also going to rewrite this in standard form. So our 2's cancel. If I look over here, the term I want first is the x squared. So we have x squared. Now I want for any x terms, x to the first power. Well, we have an x right here, and we have a minus 5x. So 1x minus 5x is minus 4x. And then we have a negative 3 minus 2 that we're going to combine to give us a minus 5, and then equals 0. So when you guys are solving your x squared equations, You've learned how to do this with factoring, with quadratic formula. Let's just hope factoring will work out just fine, so we don't have to dig into some of the more complex ways of solving. Do we have factors of -5 that add up to -4? Why, yes, we do. That's going to be a -5 and a +1. That's how we're going to get I don't know what the end of that sentence was going to be. So that gives us our factors of -5. -5 times 1 is -5. -5 plus 1 is -4. So we set each equation equal to 0. When you solve those, you get x equals +5, and you get x equals a -1. Okay, so let's bring up this idea of an extraneous solution. If you notice, we have two solutions for x, but in the very beginning, we said that x could not be a 5 or a 3. And if you look at our solutions again, we got a 5 for a solution, x equals 5. So if you go back to the original equation, what happens if you plug in a 5 in for this x? You get 5 minus 5, you get 0. This whole term is undefined, making the whole equation undefined. So we said x can't be a 5, so x can't be a 5. Are we okay with -1? -1 works out in all of our denominators. We would have caught it in our domain. The only two values x cannot be is a 5 and a 3. So our solution is just x equals -1. So that's the idea of an extraneous solution. In this example, x equals 5 is an extraneous solution because it makes the value of the denominator in the original equation equal to 0. And we can't have that, so x minus 5 is this extra solution that actually is not a true solution to our rational equation.